So, welcome everyone. Let's look at flames very fast. Why do we want to look at flames? In the laboratory, we heat substances. So we heat substances. Often we use what we call the Bunsen burner. But what kind of flame? What types of flames can the Bunsen burner produce? And what are the characteristics of these flames? And what do we really need to know such that we can also keep safe when working with different flames? Okay, so that is why we are having this session today. Okay, so when we look at the flames and combustion, the different elements that are necessary for combustion, the types of combustion, the different types of flames, and the factors that affect the flame properties. Okay? So basically, this is the flame that we are talking about. That's the flame. So flame is the burning fuel that gives out two types of energies. The heat energy and the light energy. Okay? So this here is giving us light and it's also giving us heat energy. Okay, that's what we get when we have a flame. So this part that we see, we are calling the visible part of the combustion reaction, is what we call the flame. Okay. So for any combustion to be taking place, there are three things that need to be here. The first one, fuel. The second is heat. And then the third is oxygen. Those are the three things that you need. If one of them is not there, then the fire will go off. Or you will not have combustion happening. The burning will stop. Combustion is basically burning. Okay? So let's start to look at each of the three elements and what they really mean. So we start with the fuel. Any material that can burn is what we consider as fuel. It can be wood, it can be clothes, it can be any material. Okay? It can be paper, it can be petrol. Okay? It can be anything that can catch fire. Okay? And then allows the fire to basically continue to burn. Okay, so that is fuel. So that means that the fuel is the one which provides the energy source for the fire to continue burning. So that means that if you remove the fuel, if the cloth has caught fire, you remove the cloth, that is one step towards making sure that the fire does not spread to other places. Okay. The heat is that energy, that heat energy that is required to start the burning process. Okay. If you have the cloth just like this, it will not burn unless it is subjected to a lot of heat energy, and that heat energy can come from a matchbox. It will ignite it. For other things, it can be just a small spark, and then boom, you have the fire catching up. Okay, so not every heat level will give us a fire. Okay, for example, you can't get a matchbox and have the wood, and then you think that the matchbox will actually light the wood. It will not happen. Okay, that means that the matchbox does not have the enough heat energy to light the wood, right? So that means that for burning to happen, there is a point that has to be reached that we call the ignition point. That is the temperature that is required to start a fire. Ignition is sparking that fire to set off. Okay, so we have material that can easily get ignited, and then boom, the fire also, the fire catches, okay? So we need to be careful of these things. We often call them highly flammable material. That means that they only need a small spark. Petrol, for example, is highly flammable, okay? Some clothes are also highly flammable, so we need to be very careful using them. Oxygen is always needed. Actually, when we talk about combustion, we're talking about the reaction of something with oxygen. Okay, the reaction of something with oxygen. So oxygen has to be there for combustion to take place. So oxygen combines with the fuel that we talked about in the first place to release the heat, and then the fire continuing. So if you remove the oxygen, in one way you are trying to stop the burning from continuing. Okay, so remember that air that we have around us, the 21% of it is actually oxygen, and this is often very sufficient to to support the burning that happens around us. Okay, so how to deal with the fires? Remove any of the debris. What techniques can you use? You can basically remove, for example, if it is a cloth, it is wood, it is whatever it is, remove it. That's what we are calling isolating. Remove it away, and then the fire will stop there. Okay, and then for the heat, you need to know where is the heat coming from. Sometimes it could be the petrol, it could be the paraffin, it could be a number of things. Remove. Okay, it can be electrical. It can be heat that is coming from an electrical wiring that sparks up the burning. Okay, and then removing oxygen. You can have what you call a fire blanket, fire extinguisher, which uses which gas? Tell us the gas. That is carbon dioxide, right? Yeah. So the fire extinguisher uses carbon dioxide to extinguish the fire. Okay. Well, that means to put the fire off. What it does, it displaces the oxygen and then takes over, forms a layer, and that means that oxygen does not get to the point where the burning is happening, and therefore the burning will stop, since carbon dioxide does not support burning. It says, please move away, let me occupy this place. When it occupies it, no more oxygen, no more burning. That's how the fire extinguisher works. So combustion can be in two ways. We said that you can't talk about combustion without having oxygen in the mind. So we have two types of combustion, and they're all related to the presence of oxygen. If we have a lot of oxygen, that is going to be complete combustion. Okay, a lot of oxygen, complete combustion. If we have limited oxygen, which we are saying is not enough, in chemistry we use the word limited. Limited means not enough. When you don't have enough oxygen, you have incomplete combustion. When you have enough oxygen, you have complete combustion. Okay? The products that you produce are different. For example, most of the fires involve where we have carbon burning. We get carbon dioxide when we have plenty of oxygen. If we have carbon burning, you're going to have carbon monoxide if the oxygen is in limited supply. Okay, so often complete combustion will produce this. Okay, but the other thing is that the characteristic of the flame that comes out. For complete combustion, it is blue flame, and usually very hot. That means it gives out a lot of heat. Okay, Whereas for incomplete, it gives you more light, which we call luminous flame. That yellow flame that comes out. That yellow flame gives out more light but less heat energy. For complete combustion, you have red flame, limited light but a lot of heat. Okay? So that is exactly what I've explained. This is hot. This is not very hot, but this gives more light. This gives limited light. This is complete combustion. This is incomplete combustion. Okay? Incomplete combustion here. Complete combustion here. Okay? So what factors affect the type of flame that you'll have? Definitely the type of fuel that you're having. Wood that is having, let us say, petrol sprinkled on it will burn faster compared to wood that is not having anything, right? A blanket will burn differently compared to a plastic. Okay, but all these can be what we call fuel. Then oxygen, I've explained that. Oxygen supports burning. With limited oxygen, you have yellow flame, what we call luminous flame. With the plenty of oxygen, you have blue flame, which gives limited light but a lot of heat. Okay, and then airflow. The more air flows, that means that the more you're going to have oxygen, and the more the burning will happen. So that means that if you're going to control some fires, make sure that the things that will ensure saturation to fuel the fire actually are eliminated. Okay, so that marks the end of this presentation, where we have looked at the different flames, where we have seen the characteristic in relation to the energies that they produce. Light energy and heat energy are produced, but if we have complete combustion, you have more heat energy than light energy. If you have incomplete combustion, you will have more light energy than heat energy. Thank you.